How do geodes form?
My name is Luke, and I am going to try and explain to you how a geode forms. Now, if you don't know what a geode is, I've got one somewhere on the video. I'm not quite sure where I'm going to put it when I edit this video. I've got a quartz geode which is going to be moving around in the background, so you've got a way of visualizing exactly what I mean. If you do know what a geode is, you fall into one of two categories. You either love geodes or you used to love geodes. There's no grey area. And if you used to love geodes, all that really means is you've lost that zest for life that came with being a child. So I feel for you. So a geode, which essentially derives from the Koine Greek words meaning like the earth, are essentially cavities or open spaces or orifices which occur within nature, which have crystals which form to the outside of the cavity. Comes in various different forms: quartz, amethyst, celestite. Really is contingent upon the kinds of minerals that you find in the immediate environment around the particular geode, as well as various different kinds of environmental stimulus, heat, etc., which will seed different kinds of crystals. Again, celestite, quartz, amethyst, etc., etc., etc. Now, a quartz geode, which is what I've got in the video, wherever I'm going to be putting it, is going to form as a result of a process called cavitation, which is essentially can come about in various different ways. It could be displacement of a material like a fossil or a rock, which might come about as a result of sort of earth crust displacement or some kind of seismic activity, earthquake, etc., or some kind of environmental stimulus that is going to cause a body to move from one place to another, leaving an open cavity where that thing, whatever that thing might have been, once was. Now this creates the environment in which crystals can form. Now how do they form? They form as a result of the material on the outside of a geode, if you look closely, is quite porous, quite microporous. So it means that water can fairly easily sort of pass in. Now water will kind of act as a host for various different kinds of minerals. It is essentially the canoe by which various different minerals might enter a particular environment, silicon, etc., etc., etc. So what happens to water when we heat it up? Bearing in mind that water is H2O, so hydrogen and oxygen. As we heat it up, we get vapor, or it evaporates, which means it's going to turn into a gas, which means the hydrogen and the oxygen are going to separate, which creates an opportunity for the oxygen to bind to silicon, which might be in the environment. Now, once you get oxygen and silicon, we get essentially silicon dioxide, which is essentially the ingredients for quartz. Now, what might happen now is this vapor, which is now comprised of silicon dioxide atoms, as the oxygen has bound to the silicon, is now going to cool down. Now, if you don't know, at the atomic level, when you heat something up, that atom becomes quite energetic. And what I mean by energetic is it will start to move around, be very, very erratic. It'll have a lot of movement and energy to it. As you cool down that same atom, what will happen is it will become less energetic, less erratic, less movement, and it will start to stabilize. Now, this means that the silicon dioxide can precipitate onto sort of a culture medium and then start to grow. Now, if you're picturing how a crystal might grow, imagine sort of a 3D printer, because it's probably the best way to visualize it. Those silicon dioxide atoms will layer on top of each other over long periods of time. And in the context of a geode, it's going to be forming around the outside or of that cavity. So they're going to crystallize around the outside of that cavity, leaving us with what is essentially a geode, which again can come in various different forms, and the distinction between the various different kinds of crystals is contingent upon various different kinds of environmental stimulus, in this context usually heat, and the kinds of minerals that are going to be found in the environment. Is it sulfur? Is it strontium? Is it silicon? Is it oxygen? Is it aluminium? Is it iron? If you want an amethyst geode, for example, you take exactly the same process that I have just recited and narrated to you. You add a bit of iron, maybe a touch of aluminium, add some gamma radiation, which is essentially what's going to trigger that iron to turn purple, that sort of quintessential Cadbury's colour purple, and you're left with amethyst, which is merely the purple variety of quartz. So that is more or less how geodes form. Do you like geodes? Let me know in the comments. Bye!